Fun fact, when I first started this show, my original plan was to do more video game reviews, focused mainly on the Wii and Wii U era of games that I grew up on. If you go back to the first video of this reboot, you can totally see it, a sort of review on Super Mario Galaxy. I had a joke in there where I called myself the king of motion controls, and that was sort of going to be a running bit throughout the show, me showing off how unreasonably good I am at all the crappy motion controlled games of the era. I quickly shifted away from that though when a video I made about statistically ranking every Pokemon totally blew up, and I've been diving down the math and engineering and green matrix thumbnail rabbit hole ever since. Don't get me wrong, I love these more STEM-inspired videos. I think they're way more interesting than the basic review stuff I was planning on, but it did seem for a while that my dream of stunting on the internet in Jeep thrills and iCarly was behind me. Until, that is, I had an idea. A way to return to my roots without sacrificing everything I've built. Because just because I don't play motion control games every week, that doesn't mean I still can't wear the crown. For one day only, I'm bringing together my years spent being forged by Survivor minigames and combining it with my real-life mechanical engineering degree, and we're going to learn how exactly a Wii remote works. Richard, hit that intro. Hey, before getting into the actual video, YouTube doesn't really like it when you make a video that deviates even slightly from the highly specific niche that it puts you in, and I have a feeling that it's going to try and bury this video in a shallow grave. So do me a solid and hit that subscribe button if you haven't already, and maybe share this video with a friend, and together we can vanquish that almighty tyrant. We will not go quietly into the night. So, the Wii Remote. How does it work? I'm sure a lot of you are thinking, I don't know, magic? Well, no, not quite. Magic isn't real, but mathgic. Nope, I'm gonna stop that one right there. It sounded funny in my head, but now that I'm saying that out loud, I hate myself for even thinking of it. For as small and simple as a Wii Remote seems, there's actually a lot packed into this little shell. Of course, there's things like the battery pack, the buttons, the rumble, things that pretty much every game controller has, and that I could honestly care less about. But like, only a little bit. Like, I guess it could be interesting. I could see myself caring, but not that, oh, you don't care? Nope, I'll shut up. The part that I'm the most interested in is, surprise, surprise, motion controls. There are actually two different systems in here that make motion controls possible. The linear accelerometers and the infrared sensors. So let's bust this thing open and see what we can learn. I got no idea what any of this is. Yeah, like I mentioned before, my background is in mechanical engineering. So if you want to talk about gears, forces, pulleys, I'm your guy. But all this circuitry stuff, look, I took one electrical engineering course 4 years ago that had a 3-hour-long lab at 8 a.m. So safe to say that I never really learned that much. All that is to say, I'm going to try my best to explain the electronics behind this stuff, but it's going to be real dumbed down because my brain was starting to melt when researching this stuff. Let's start with the first of the two systems, the linear accelerometer. To understand how this works though, we first need to understand a little thing called a capacitor. When you have two parallel plates of some conductive material, like some type of metal, with empty space in between, and you connect these two plates to a circuit and power it, a charge builds up on one of the plates. This creates an electric field between the two plates because this one might actually be magic. This whole situation here is what we call capacitance. Now, the capacitance can change depending on a lot of things, the voltage you're running through it, the size of the plates, or the most important for us, the distance between the plates. Say we placed a weight on one of these plates, causing it to compress down a bit. This would change the capacitance, and if we could measure how much the capacitance changes and do a whole bunch of math, then we can figure out how much the thing weighs. The weight of something is just the force of gravity acting upon it. Force is related to acceleration, hence the name accelerometer. This is an overly simplified version. Most real accelerometers would have a whole bunch of plates stacked on top of each other, but in essence, they measure the force of something. Now, they can be used to measure a lot of different types of forces, but we only care about one force. The one force. It surrounds us, it binds us, it holds the galaxy together. Whoa! In the case of the Wii Remote, the accelerometer is used to measure gravity. Now, the force of gravity here on Earth is always a constant 9.8 meters per second squared. So, if you held an accelerometer out like this, it would sense an acceleration of 9.8 meters per second squared. But what if you did this? Gravity always acts straight down, but now our accelerometer is at an angle. It only senses forces that are perpendicular, that are coming right at it head on. So now it's only getting a fraction of the force. If we know the acceleration is supposed to be 9.8 if it's perfectly flat, and we can measure what the force actually is with the changing capacitance, then with some more magic, I've come back around to it, we can figure out the exact angle that the Wii Remote is tilted at. So just to recap, if I lost you there, the accelerometer uses a lot of fancy circuitry and math to figure out the angle that the Wii Remote is pointed at relative to the ground. But, as I'm sure you've all noticed, we live in a three-dimensional world. So the Wii Remote actually has three of these linear accelerometers. One for this axis, one for this axis, and one for this axis. Combine them all together, and you can sense the exact orientation of a Wii Remote, no matter what it is. You may remember that a couple of years into the Wii's lifetime, they released a thing called the Wii Motion Plus, that little end bit that Wii Sports Resort kept making you recalibrate every 5 seconds. That uses a system called a gyroscope that accomplishes basically the same thing as the linear accelerometers, just in a different way that's a lot more accurate. So great, we got some fancy linear accelerometers that can measure which side I'm trying to flip that chimp to, but there's still a problem. These tell us the orientation of the Wii Remote, but not its physical position. If you're doing a lot of this action to select which crazy eyebrow to give your Mii, the accelerometer isn't going to help you at all. That's where the infrared sensors come in. This little bit on the front here. Time to bust out those sensor bars, everyone. Infrared light is basically a type of light that we can't see with the naked eye. You know how if you play a super high-pitched sound, people can't hear it, but any dog within a 3-mile radius will start losing their minds? Infrared light is kind of like that. It has a frequency that is higher than what our eyes can detect, but an infrared sensor, or IR sensor for short, can detect it. And in fact, that's all it can do. It's infrared sensor. It senses infrared light. That's it. Now, I always thought that the Wii Remote let out the IR light and the bar below your TV would pick it up, but that's not actually true. Despite the fact that it's called a sensor bar, this bar doesn't actually do any sensing. Instead, it's basically just a fancy lamp. These two glossy bits on the end here have infrared lights in them, and the remote has the sensor. The light leaves the bar and is picked up by the remote, which can measure the angle that the light is coming from. If we know that the light sources are always the same distance apart, then you know the drill by this point. Math, math, math. We can figure out how far away the Wii Remote is from the TV and where it's pointed. Mind-bogglingly, this means that if you ever lose your sensor bar or it breaks or something, all you gotta do is light 2 candles and place them below the TV. Sounds crazy, but the bar doesn't actually send any information to the Wii. This cable right here is just to power the lights. So anything that emits some infrared light will work. Pretty crazy stuff. Nowadays, nearly every controller comes with a gyroscope, and VR is doing things with motion controls that would make the Wii swoon, but it all had to start somewhere. And somehow, knowing the elegant little systems that allowed grandmas all over the world to hurl chunks of plastic into their TV while trying to bowl, it just makes me appreciate them even more. But it just goes to show...
Look, I'm pressing the button. I am telling you nothing is happening.
Hello?
Yeah, I think I got it. Can you hear me?
Richard? Richard, what the hell's going on?
Finally, so, Mr. Chiptide, we finally meet. I must admit, I'm impressed you managed to evade me for this long, but I'm afraid you've been running your mouth for far too long.
What are you talking about?
It's about time that the people learn the truth, that you are nothing more than a charlatan, a jester wearing a crown that does not belong to you, sitting upon your throne of lies.
I think you might have the wrong guy?
No, I am quite sure. The time has come for me to set the record straight and put your outlandish claims to rest. But if you want to prove me wrong, you know where to find me.
I don't actually know.
I sent some directions to your assistant. If you just have like a GPS or something, she'll be able to plug it in, find me just fine.
Oh, cool.
Well, boy, I will see you very, very soon.
Richard, pack some sandwiches and fire up the spaceship. We got a finale to make.